Guys, this is week 3 of 6. This booklet's actually following on from week 1 of 6. They are both calculator booklets. Okay, so actually what we start with in this calculator booklet, okay, so a paper 2 booklet, is a recap of booklet 1, some questions that I've pulled from booklet 1 for us to have a look at. Okay, then we're going to have a look at rounding. You're not going to get a specific question on rounding, but you will get a couple of questions that say, and you've got to read, really read the question before you start. So my big advice is read the question. 2 things. What does it ask for? How does it want it written? Do I have to include units? If it says to, do I have to round it to 1 decimal place? Read the question. Is it actually asking, is someone correct? In which case the answer is yes or no, rather than just a number, okay? Don't lose marks for not answering what the question says properly. That's enough of that rant. So we're going to recap of booklet 1, then we're into a bit of rounding, as we said, a bit of indices. Now, you can use your index rules here, but I'm going to concentrate on indices in booklet 6, actually, which is a non-calculator one. However, they can appear in a calculator paper as well, where you can just put them in your calculator and then round your answer. We'll have a look at examples in a second. A bit of rational and irrational numbers. Again, normally linked to surds. But what we might get in a paper in this booklet is give me 2 irrational numbers that multiply to make a rational. I don't know. We'll look at questions there anyway. Substitution, again, can't see there being a specific question on substitution, but you'll need to know how to substitute in other things like trial and improvement. Okay, that's a substitution question. Simultaneous equations involve substitution at the end. So we'll just have a little look at it, okay? Sine and cosine rule, higher tier. Again, everything in bold is higher tier. Okay, easier probability, so tree diagrams and using decimals, etc. And then the last thing is that very last question in paper 2, which we'll do here, conditional probability, where the first event affects the probability of the second one. For example, a marble is not put back in, or without replacement is the words. That's enough talk anyway. The first bit is actually, I've done a bit of work in here already to make it easier for you, okay? This is a question that was in booklet 1, a trial and improvement. Look at it, recognise what a trial and improvement question would look like, okay? What we've got here, when I tried 1.5, you will have to do workings, it was too small. So I went up to 1.6, still too small. So I went up to 1.7 and the answer was too big. So the answer was between 1.6 and 1.7. Therefore I checked 1.65, which was in the middle. That was too big. Therefore the answer is smaller than that check. So it's 1.6. Finding original amounts, a number when decreased by 12%. Well, to decrease a number by 12%, we would times by 0.88, which is 12% less than 1, okay? But 3,600 is the answer. What's the original number? Well, we need to reverse that. To find an original amount, we're dividing by the multiplier rather than multiplying by the multiplier, okay? So that was my answer to 1 decimal place. Another one for you to look at, how do I reverse a 4% increase? Well, to reverse a 4% increase, instead of times in by 1.04, I would divide by 1.04. Upper and lower bounds, I've missed a step here. I would start by writing all my upper bounds and all my lower bounds, listing them. So the upper bounds of the length of the rectangle here is, well, it's the nearest centimetre, so add half a centimetre, 24.5, and 23.5 lower bound. And this one, add half a centimetre, 15.5, and 14.5 lower bound. And it wants the greatest possible perimeter, so I've added up all the upper bounds all the way around the rectangle, and the least perimeter, per standing for perimeter, I've added up all the lower bounds. And when I've added them up, I've got 80 as my greatest, 76 as my least, and if I answer the question, it asks for the difference between, which is 4 centimetres. Similar shapes, again, sorry if this is a waste of time, you've already revised it all. It's given me 2 volumes of 2 different shapes. I've divided them to get my volume scale factor, cube rooted it to get my length scale factor, and then the radius, which is a length on the smaller cone, is 2.3. So on the bigger cone, I would times that by my length scale factor to get 9.2 centimetres. Simultaneous equations. I've only had to change the bottom equation here. I've times the bottom equation by 3, so my coefficients of y, my numbers before y, are the same. Here they are. Everything in the bottom is times by 3. I've done, because they're both negatives, same sides subtract, but because my bigger numbers are on the bottom, I've done the bottom numbers, subtract the top numbers. So we've got 4x equals 27, take away 11, which is 16. So x equals 4. Substituted that into the first equation. So instead of writing 5x like it is there, I've written 5 times 4, which is 20, minus 3y equals 11. I don't like my subject term, which is my y's. That's what I'm trying to find. I don't like it being minus 3y. So to negate that, to get rid of it being negative, I've moved that to the right-hand side of the equation and brought the numbers to the left-hand side of the equation. And you can just look through my answer there, giving you y equals 3. And then a little bit of trigonometry, first of all. I know a side, I know an angle of a right angle triangle. So this is SOHCAHTOA. Think that through. Right angle triangle, know a side, know an angle. SOHCAHTOA, and I've done it there. And a little bit more to do here, but again, something I've stolen from booklet 1, so we've been through, where you use the area of the right angle triangle to work out the missing height. So I've halved the base, which is 12. 12 times what would make 84? 7. So the height is 7. Then I've used the base and the height with Pythagoras' theorem to work out the big side, the hypotenuse, which if you see my workings here, square, square, add square root. The answer is 25. And then I've added the 3 sides together down here to give my final answer. And finally, we're into this booklet. Rounding. Okay. You try them. Come to me if there's a problem. 1 decimal place, first of all. So cutting off after the first decimal place. So chopping the number here, here, and here. And if the number after where we chop off is 5 or more, rounding up. Otherwise, stays the same. Check those answers. 2 decimal places, chopping off after the second decimal place. And if the number after the chop off point is more than 5, rounding up. Otherwise, it stays the same. There's a lot of work goes into that there, right? First significant figure, the first non-zero digit in the number, round into that. So here it's the 9, which because it's followed by a 3, stays as a 9, but everything else is 0, so the 9,000. Here the first significant figure is the 3 there, but because it's followed by a 7, it goes up to a 4. And here it's a 6, but we'll round up to a 7, and you can look at my answers there. Pause if you need to at any point. And 2 significant figures, I've highlighted here the second non-zero number, okay, after the first significant figure. So here's the 8, here's the 2, here's the 2. And then looked at the digit after it. So here it's a 9, so the 8 rounds up to a 9, 5,900. Here the 2 is followed by a 6, so rounds up to a 3, 13. And here the 2 is followed by a 7, so rounds up to a 3, so 3.3. Notice I don't need to put on the end of these bottom to 0.00 or 0.00. You don't need zeros after the point. However, in bigger numbers, obviously we do. You do need to fill those places here with zeros, otherwise you kind of lose the value of the 5 and the 8. 5,892 becomes 5,900. Hopefully that makes sense. Again, not much to say on the next section, indices with a calculator. I've dumped all these into my calculator. All I've written here, if it doesn't make sense, is I wanted to show you that calculator button, which allows you to put that 5 there. Okay, so if you press that button, it will allow you to put the 5 as an indice to work that out. Do this as it looks, put brackets in, use the power button, and then use the fraction button. So start with that button, and then after it, find the fraction button to write the indice as a fraction. Here, my calculator gave me the answer is 8 times 10 to the power minus 3, but I know that. Just move the decimal point back 3 places, 1, 2, 3. So it's 0.008, just writing it in standard form, be careful of that. Again, you have a look at my answers, try them first and then look at them. I've done them for you. I'll pick up on Aaron's claim here that if you square a number, it can't be smaller. He's probably right in 99% of the cases, isn't he? Because 2 squared is 4 and 3 squared is 9, so the answer is always bigger. But if the number you're squaring is less than 1, the answer becomes smaller. And there's an example here. 0.7 times 0.7 is 0.49, which is smaller than 0.7. So squaring a decimal number, just be aware of that, makes the answer smaller. They get a little bit harder now because they're talking about rounding your answers. So 3 significant figures, the third figure there, followed by a 3, so stays as a 7. 2 significant figures here is 130. And you can try put these into your calculator here, try and round it to the nearest 10, etc. I suggest you do all these, pause and just check the answers. I haven't done them all. Just keep an eye on what you're rounding to if you get one. Okay, but use your calculator. Okay, rational and irrational numbers. So, an irrational number is a number that continues without any repetition, without recurring. A decimal number continues forever. There are a few that we're aware of. Okay, any surd, and by that I mean a square root without an answer. So something like the square root of 15, square root of 3, square root of 7, there's loads of them, okay? Any surd is irrational. Also, any cubed root or fourth root, in fact, any root, be it square root, cube root, fourth root, whatever, as long as it doesn't have an answer, which is a whole number, it will be irrational, okay? So that's your first thing. Square roots, cube roots, fourth roots without an answer. The other number which is irrational is pi, but even if you square pi or cube pi, it's still irrational, okay? Anything else, as far as you're concerned, for the GCSE is rational. I need to have a sip of water. 2 seconds. Okay. I am not going to go over this one and the bottom one, or I might do the bottom one, because it's in booklet 6, and I will go over it there, because it is more likely that we'll get a question like this in the non-calculator paper, okay, because we'd have to work out the surds. I only included this because it said, is the answer rational or irrational, and we know a question like that is going to come up in the calculator paper, okay? This is my preference here, I would think, in terms of how we're predicting. So, pi times pi is pi squared, which you can do it as a decimal if you want, which is still irrational. The square root of 7 times the square root of 7 is 7, which is rational. However, the square root of 7 times the square root of 3 is the square root of 21, which does not have a square root, therefore is still irrational. And finally, the square root of 8, which is irrational, times the square root of 2, which is irrational, because neither of those have answers, gives you the square root of 16, which does have an answer. It is 4, therefore it is rational. So I'm looking for things here, I think, like give me 2 numbers that multiply to give an irrational, or whatever it is. Okay, so let's have a look at these. Give one example to show that the square of an irrational number is not always rational. So first of all, an irrational number which we're going to square, which means times by itself. Well, we only know 2 types of irrational number. We got pi and we've got a square root, I guess. But if we square a square root, like here, we know that the answer is going to be rational. So my only option here is pi. And when I square it, I can either write that as just pi squared, or you could even put that in your calculator and just put a few decimal places and put it like a dot, dot, dot on the end just to show it keeps going. Okay, and that'll be your mark for that one, because the square of pi, as we know, is still irrational. Okay, find 2, and here's the interesting one here. They've got to be different irrational numbers, and we want the answer to be rational. Well, my best bet here is something like the one I did here. Pick anything. We can go for the square root of 12, which we know is irrational. The square root of 3, which we know is irrational. But when we multiply them, because when we multiply them we get 36, which is a square number, we know that that is 6. So the answer is rational. So 2 different irrational numbers that multiply to make a rational answer. And I can put those. Oh, and part C. Here we go. Give one example of an irrational number whose square is rational. Okay, anything. Because when I square it, so just, yeah, look out for questions like that. Again, look to booklet 6 for examples of where we have to kind of simplify and work with surds. Okay, which one of the following numbers is rational? Pi is irrational. That doesn't have an answer, so that's irrational. 16 doesn't have a cube root, does it? Because 2 times 2 times 2 is 8, and 4 times 4 times 4 is 64. So 16 doesn't have a cube root, so that's irrational. Okay, 20 doesn't have a fourth root. There's no number that if you times it by itself 4 times you get 20. Don't say 5, because that's adding, not times. Then 5 times 5 times 5, oh, it's just a huge number. So 20 doesn't have a fourth root. However, if we cube root both of these, the cube root of 125 is 5, and the cube root of 8 is 2. So that becomes 5 over 2, which is 2.5, which is rational. Boom, take that one, okay? Which of the following is irrational? Well, that will go on forever, but there's a pattern to it. There's a recurrence, so it's not that, okay? The answer to that is 12, which is rational, so it's not that. Here we would square the top 9 and square the bottom, so it can be written as a fraction. So it's not that. Does 16 have a cube root? No, it doesn't, so it's irrational. So it's a cube root without an answer. And we also know pi squared is, so there's 2 answers there. Oops, that are, and I've checked and checked and checked that. That should be a 2 marker. I just typed it up wrong. Substitution. Okay, look, the way I take what I want these numbers to be, like x is minus 3, and where I see x, I just put it in brackets, shove it in your calculator, boom, boom. These two are a little bit harder. I've done one in full. This one I've just given you the answer, but I want you to do the workings out. Okay, so here we're told the answer n is 26, and one of the letters is 2, D, and we've got to find E. So I've written it in full. Instead of n, I've written 26. Instead of 7D, I've written 7 times 2. What I don't know is the value of E, which I've written 3E. 7 2s are 14. Over the other side is minus 14. So 26 take away 14 is 12. So E is 4, and you can try this one. Pause, take a look, make sure that makes sense to you. Let me know if it doesn't. Losing my voice a little bit. I want to rush through this section and get on to trigonometry. I'm going to take a break after this section and then come back to this video. So I've already written some notes, but I haven't done any work on it, okay? So if we have a triplet, an SAS triplet, in other words, a side, angle, and side given to us, that sort of triplet there, okay? There are 2 things it can ask us for. We can use the cosine rule to work out the other side, or we can use the area rule to find the area. And it depends what the question is talking about as to which we use. If we have a complete and an incomplete pair, we will use the sine rule. We'll see that in a second, what I mean by that. If we know all 3 sides of the triangle, and happy face, don't like this one, it's the cosine rule to find an angle. Oh, it takes a bit of rearranging. It's not nice. Worst one, least asked question of them all. Let's hope for the best, but we'll do an example to make sure we're okay. And remember, if we know 2 angles in a triangle, a la here and here, then we actually can work that one out if we need to, right? So you might go, oh, I didn't have enough information. Well, if you know 2 angles, you can always work out the third, and then you've got more information that you can potentially use. Anyway, we'll look at examples now. Okay, I'm not going to do the easy ones. I'm just going to point you on your way on the easy ones, and I'm going to pick some harder ones to try, because I haven't done any more of this booklet. So in the first one, work out the length of BC here. I don't know a triplet, but what I do have is 1 complete pair and 1 incomplete pair. So it's the sine rule, but to find this side. So the side goes first over sine 33 equals, and then the other side, the complete pair, which is 15 over sine 112. And all we would need to do here, guys, is take the sine 33 up there as a times. You can use brackets around the angles, okay? And that'll give you your answer to that. Maybe you give your answer to 1 decimal place. Calculate the area of the triangle. Perfect, I've got everything I need. Got the triplet that I need. So it's half. This can be A. Don't have to learn this, remember. This can be B. Sine the angle, which is 60, which becomes big C, because that's little c. Okay? Again, work it out, give your answer to one decimal place. Here, I'm looking at it, I don't know a triplet, okay? But what I have, I can see already, is I've got this complete pair. All right, maybe that will help. We'll have a look now, okay? Calculate the size of angle ABC, this one. Okay, so this is my incomplete pair in this case. But because I want the angles go on top of the sine rule. So sine, call it x, call it theta, call it whatever you want to call it. This, okay, let's call it theta. You don't know it, okay? Divided by his partner, who is 20, equals sine 60 divided by his partner, 18. Okay. Again, ladies and gentlemen, the divide by 20 will need to go up there as a times 20. Put that in your calculator, and hopefully the answer still is something like 0 point something. Don't forget then, to get theta, you'll need to take the sine over. And whatever your answer to this sum was, can go in there. Whenever you're finding an angle, you've got to use the inverse, so sine minus 1 or cos minus 1 or tan minus 1. Triplet again, this time to find the length of BC. Alright, so it's not the area, it's the triplet with the cosine rule. So A squared, this becomes A, equals B squared, this can become B, plus C squared, this can become C, my apologies, minus 2 BC cos big A. Okay. Again, I'm not going to go into it. You just put, and obviously the angle there is big A. So you've got the three things you need. Just put them in brackets, whatever, and throw it in your calculator. Remember, though, to find A, because it's A squared, this side, you will need to square root whatever that works out to be. Okay? This is the dodgy one. Find the size of XZY, which is this angle. Because it's this angle, this becomes big A, so this becomes little a. And the other sides become B and C. Okay? Oh, so dodgy, right? You've got to rearrange. You've got to rearrange the cosine rule. So, if I just show you the cosine rule again, which is here, right? Let me draw this arrow to here and start doing this here. Here's what I do. I bring the A squared over that way, and the minus 2BC cos A, I take the other way instead. So it becomes 2BC, oh, pen is going bad, cos A equals B squared plus C squared. And because we're bringing the A squared over to the right hand side, it becomes minus A squared. So cos A equals B squared, which we know is 22 in this example, plus C squared, which we know is 20 squared in this example. Take away A squared, which we know is 17 in this example, all divided by this bit here, which is times in the cos A. Well, the opposite of times in is to divide by this. Again, put everything in brackets, but then remember to, at the end, you've got a cos minus 1, whatever your answer to that is. Difficult thing to learn. Difficult thing to learn. Right, we're into our have a go yourself, okay? So have a think about it. Complete pair. Calculate the length of AB. Yikes. Here's the incomplete pair, isn't it? But, doesn't help me. But like I said, whenever you know two angles, you can work out the third. That is 180 take away 96 and also take away 31, right, which is 84, I think, 53, just double check that because I'm rushing you. So that is an important angle because then this is the important pair to get x. So use your sine rule to try and work out x, knowing a complete pair and now that incomplete pair. Size of CAB, chance for you to practice that horrible one. Okay, have practice of it, so that's using the cosine rule to find an angle like question 11 there. Now some connected things, okay. Calculate the length of CD. Okay, well, to know that, I'm thinking, well, what I probably need to do here is work at this angle, because these two angles are equal because they are opposite. All right, so if I needed a reason, they are equal because they are opposite each other. Right, so once I know that angle there, I can say, well, that's the same, and then I will have this triplet, and I can use the cosine rule. A squared equals, etc., etc. But how am I going to get this angle? Well, on this triangle, I've got that complete pair, and luckily here, nice, thanks very much, I've got that incomplete pair there. So work out the angle with the sine rule, and then use the cosine rule on the second triangle to get the side. Here, calculate the area of the shaded region. All right, lovely. DE is 8. EC is 9. That triplet allows me to do two things. It allows me to work out the length of here, A, because that becomes big A, and these can become B and C in any order. So using the cosine rule, I can get that. It also allows me to work out the area if I would prefer, if I need to. Yikes. Area. Which I might need as well, so, okay. And I'm told that ABCD is a square. So let me talk you through this. First of all, find A using the cosine rule. Part 2. Find area. Really gone now. Find the area of the square. Because whatever the length A is, it's a square. So all the sides are the same. So whatever the length of A is, A times A will give me the area of the square. Then find the area of the triangle. Pen, don't let me down. Oh dear me, it's just squiggles. Find the area of the triangle using half AB sine C. Okay, so using the same triplet as you used for there, and then take them away from each other. Okay, because it's a triangle cut out from the square, isn't it? So I'll just put, because my pen is going so bad, I'll just put subtract. What else have we got? Calculate the area of ACD. So I need the area of this. For an area, I'm going to need a triplet. But that triplet is missing that side. How can I work out that side, which I'll need for the area? Well, here, I've got the triplet. So I can use the cosine rule to get the missing side. And then once I've got the missing side, get the area from there. Here, what have I got? Right. I'm not even reading the question. I'm just going to circle things. I've got a complete pair. I've got an incomplete pair. I can definitely work that angle out with the sine rule. Once I know that angle, if I need to, I can also work out that angle because I'll know 2 out of the 3 angles in that triangle, so I can get the third. It wants the length EC, which is this. Okay, once I know that side, I can potentially use the cosine rule with this number, this angle, and this side. That triplet to get side X, that will help me there. Here, I've also got a complete pair there and an incomplete pair there, which will allow me to work out this side. And once I know the 2 X's, right, from using both of the side triangles, I then have a triplet from the middle triangle because I know this angle is 26 and I'll know both my missing sides there. So I've got that triplet, and I'm sure Part B will ask me for the length BC. There we go. So we work that one out. Well, that one can be a squared equals, b squared plus c squared. Sorry, that's just a bit of a mess. Hopefully that made sense to you. Come to me if it doesn't. Walk you through the next question, okay? By first calculating the size of BAC, calculate the area of a triangle. Well, to get an area of a triangle in these questions, we know that we're going to be using half AB sine C. So we know we're going to need a triplet, an SAS triplet, side with the angle in between those two sides, that triplet we keep talking about. And when you look at that question, by first calculating the size of BAC, well, BAC is this angle up here, angle A up here. But actually, given that the two sides I know are this one and this one, it almost strikes the question, well, why am I working at that angle when the angle I need is the angle between those two sides to give me that triplet, so that I can do this? I can use half AB sine C, right? But they're asking me to work at this angle. So what we'll have to twig there is, okay, they're asking me to work at that angle because of the sine rule. I've got a complete pair here, 46 with 5.3, and an incomplete pair here with 6.4 and an unknown angle. So if I use the sine rule, putting that angle on the top and dividing it by 6.4 equals sine 46 divided by 5.3. The opposite of dividing by 6.4 is timesing by it. I get that, 0.8686. It's a bit more than that, but I thought 4 decimal places is enough. But then to find that angle, take the sine over sine minus 1, and I get that. Not the angle I wanted though, but it goes back to that thing again of keeping an eye on when I know two angles, I actually know all the angles. So even though I've used the sine rule to work that one out, the one that's important to me is this, what I've labelled big C here, which I get by doing 180. Take away the 46, which is angle B. Take away the 60.3, which I've just worked out to be angle A, gives me 73.7. And that is the angle I will use in this formula, which you can have a go at. I haven't got the final answer. And the final one again, ladies and gentlemen, I've got a complete pair and an incomplete pair, which I can use to find X, right? But it asks me, so that would be BD, so that would be taking care of that part. That's a nice easy part, okay? But then the second part asks me for the length of AD, which is this. Well, to get that, it looks like if I know this side now, this other X here, and I know this side is 8, I'm looking for that triplet, and then I can use the cosine rule, a squared equals b squared, blah, 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 blah. But I still don't know this angle, and that took me a little while to work out. But again, it comes down to that. If I know two angles, I know all three angles. So if I know that that's 50 and that's 48 in the second triangle, I can work out the shaded in one here by taking those two away from 180. And then once I know that one, the stripy angle and the shaded in angle must add up to 180. So I can take that coloured in angle away from 180 to get the stripy one. And then I've got all three bits that I need for that. If that doesn't make sense, come and see me. On to our next section, tree diagrams. Okay, the big things here, what they look like, take a look just in case you have to draw one. Two events. In this example, the events are the gender of the person and the transport that they use. Okay, they're always going to be what we would call independent in a tree diagram. Okay, in that event 1 doesn't change what happens in event 2. So here, whether you're male or female, the probabilities of walking and train are the same. In other words, what that's saying is you can copy this branch down here effectively. Okay. The other feature here is the labels are at the end of the branches, and the probabilities are on the branches. So take a look at what that looks like. Where did I get my numbers from? It told me that the probability of someone taking the train is 0.35, which is what I've put there. Okay. And then I've used the fact that every pair of branches adds up to 1 to work out that the other missing number there is 0.65 and there's 0.58. The other thing I want to point out that every part B is about combinations. This followed by this and this. And the word and means times. Okay, so if I wanted female and walk, I would times female and walk. I would times those numbers, always times in, to give me the probability of female and walking. What does my one ask for here? What is the probability that the person is female and travelled by train, female and train, and I multiply them together to get my answer. Okay, a bit of a mishmash here because we've got the first event method of travel with probabilities as decimals and the second event with probabilities as fractions. But again, every branch adds up to 1. And again, I didn't like the wording, okay? What's the probability that the person was not one of those who travelled by bus on the first day of the show? Right? So I'm almost thinking, okay, if you went up this path, you went by bus on the first day of the show, which is not what I want. Okay? If you go up and then down, you went by bus on another day, which is okay. Yeah? Or if you do either of the bottom two, car first day or car other day, and I've ticked all of the combinations that work. The only one I haven't ticked is the people who did go by bus on the first day, because it is not those that I want. Okay? So what I've done is I've done this times this times this, and then this times this. Worked out the 3 combinations separately, all with times in, and added them together. And then I've given my answer. You can either give it as a fraction or a decimal, either or. No need to give it as a percentage, even though, you know, some of you are clever enough to know that 0.42 is 42%. I would prefer you in these actually to keep your answers as either fractions or decimals. A little bit of a variation here, the one I'm going to do, and be careful of this. A lot of people are going, right, let's put Ryder there, I can get that number right, no problem. I'm now looking at the question for one of these so I can fill this side in, stops for a break. And all you will see is this, stops for a break is 0.42, and you will put 0.12 there. Yes, if you stop for a break, it's 0.42, but you read, and there's a word in bold. The probability that he travels through Ryder and stops for a break is 0.42. They have given you the probability of that combination. Okay, you almost have to work backwards and divide that by 0.7 to realise, well, actually, it's 0.7 times 6 or 0.7 times 0.6, which will give me that. And so it's slight variation. Watch out for that word and, because what they've told you there is an answer to work backwards. Okay, if that's 0.6 though, that's 0.4, and the same down here. And then my part B, I need to read what combo are they interested in. They are interested in someone who travels through Hereford but does not stop for a break. Hereford but does not stop for a break. Into your calculator, or I'm sure you could do that one in your head. There we go. Bit of a weird looking one because the first event has 3 choices, A, B or C. Just be careful here though, right? What is the probability that a player will select a black ball? I have seen so many people go, oh well, that's black, and that's black, and that's a black ball selected, so I just add those together. No, no, no. Combination 1 is A with a black ball, which I'm working out there. Combination 2 is B with a black ball. And combination 3 is C with a black ball. All 3 worked out separately and then added together to get my combined thing here, which is 0.655. Now, I've written that as approximately 2/3. You wouldn't write that in the exam. The only reason I've done that is because it leads me on to this part. 0.666666666 is 2/3. That's pretty close to that. So if it said, what's that approximately as a fraction, you'd say 2/3. Therefore, approximately what is the fraction of getting a white ball? Well, if it's approximately 2/3 to get a black ball, it's approximately 1/3 to get a white ball. Okay? Another one with the magic and. 0.24 is the probability that she goes on a tour bus and sees the show at the Millennium. So you've got to work backwards then to see what that is, and then you can fill all that in and you can try part B. Okay, have a look at this again, fill in the missing one there, fill in the missing one there, copy those down. Alright, calculate the probability that the meeting is held on a Saturday and that Alwina travels by plane or by car. So that's Saturday with plane, Saturday with car, work them both out, add them together. On to the next section, okay? So not tree diagrams, maybe using a bit more decimals now, but without the tree diagram. Let's talk through a couple of these. The probability of selecting a blue ball from this bag is 0.3. More than half the balls are blue. Well, it can't be because the probability of getting a blue is less than a half. So we just write that, okay? Incorrect because the probability is less than half. What is the probability that selecting a ball is not blue? Well, if 0.3 are blue, 0.7 are not blue. And if there are 50 balls in the bag, how many of them are blue? Okay, if the probability of getting blue is 0.3 or 30%, okay, then 30% of my balls in this are blue in here, okay? So you would just do 0.3 times 50 or work out 30% of 50. But given you've got a calculator, you're probably best going with that, which is 15, okay? Again, it's almost like a branch of a tree diagram, but with a missing branch, okay? Add up what we know, 48, 0.48 should say, 0.72 they add up to. So the missing one is 1 take away that, which is 0.28. And if there are 522 discs showing a picture of Caernarvon Castle, right, so that's the probability. So 36% or 0.36 is that. It's asking how many showed Harlech Castle, which is this. Now, just compare the amounts. You can see that that goes into that 3 times. So all I've got to do here is I would have a third as many, or I need to divide that by 3 and work that out. I'm not going to do that right now. Right, the more standard question on these pages. You've got 3 or 4 the same here now, okay? We'll do one of them. I'll take randomly, I'll go to this one, okay? So, missing number, part A, fill in the missing number. Add up what you've got, take it away from 1. Easy bit. Okay, pen's going all over the place again. Part B. What is the probability that on a randomly chosen day she travelled to work by car or? So this is an or question. In other words, we're allowing this number or this number to happen. There's only one event. She's going to work for that one day or. So or is add together car or bus and they add together to give that. So that's one event and I'm allowing this or this added together. Whereas part C, what is the probability that in a randomly chosen week, Maya travels to work by car on a Monday and, another word for and then, so this followed by this, then this and this happening. Okay, now this is your times question because there's 2 events, much like the tree diagram. We want the car on the Monday, then or and the bus on the Tuesday. So this is where we do multiply them. And if you put those into your calculator, all the effective times it by 0.1 on this actually is just that it makes it 0.025. And every question here, look, missing number or and. Yeah. Missing number. Okay, Sasha is an identical set of cards. There's only one missing part here. Oh no, there we go. Here's your part B, sorry. Or, east or south. And then this. What is the probability they both choose north? In other words, north for the first person and north for the second person. Okay, what's going down at the end here? A couple of ones that I want to mention at the end. A fair 6-sided dice is thrown. What is the probability that a 3 is thrown on both occasions? So a 6, then, and a 6. So the chances of getting a 3 on the first throw at 1 out of 6, and then followed by another 3. Again, the probability is 1 out of 6. So it's 1 out of 36. Okay? This time we're talking about a dice and a coin. The dice, 1 out of 6 for every probability. The coin, 1 out of 2, heads or tails. Okay, how many outcomes are there? Well, every outcome is 1 over 12. There are 12 outcomes here. Heads with a 1, heads with a 2, tails with a 1, blah, blah, blah. What's the probability of getting a 4 on the dice and a tail on the coin? Well, we've already answered that. That's one combination of the 12. Or a multiple of 3 on the dice, which is 2 out of 6, 3 and 6. And then a heads on the coin, which is 1 out of 2, and that would be 2 out of 12. But because I can't see 2 out of 12, it would simplify to 1 over 6. So it's a knowledge in this section that if I want two things to happen, 2 coins, 2 dice, 2 decimal things on the last questions, I times them together if I want them both to happen. But if it's an or, I add them together. And finally, our A-star questions. Okay, this is the one I'm interested in, at least one, right? Part A, normally 1 or 2 combinations, normally 1. Part B, if there is one, a couple more, 2 or 3 combinations to add together. Part C could be many, 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 many combinations, but if there's too many to list, we will do the opposite of what they're asking and take it away from 1. So here, it says at least 1 pinto bean. The opposite of having at least 1, so 1 or 2 or 3 pinto beans, is to have none. No pinto beans. And that's what I'm going to work out right here, okay? So look at that, at least one, think of the opposite. So here, we've got 6 kidney beans, 9 pinto beans, and 10 black-eyed beans, and so 25 in total. 2 are selected at random. Okay, that's not so bad. Without replacement. We're not putting it back in. It's conditional, it's dependent. It's an A-star question, okay? What is the probability that the first is a kidney bean? 6 out of 25. Then, followed by a pinto bean, which is 9 out of, but there's now only 24 left, into your calculator, and you will get 54. And do not try to simplify this, okay? I would rather you not put in, I would rather you kind of work at the top and bottom separately, so that everything is out of the same number, okay? Otherwise your calculator will simplify it for you, and I don't like that. Both beans the same type, so here we can have a kidney followed by a kidney. We could have a pinto followed by a pinto, or we could have a black-eyed bean followed by a black-eyed bean. Okay? Work out, work out, work out, and then add them all up. Calculate the probability that at least one pinto bean is selected. You'll be there all day going, oh, a pinto with this, a pinto with that. That with a pinto, that with a pinto. 2 pinto, it'll take you all day. So, group everything else into not pinto. There are 16, 6 and 10 that are not pinto beans out of 25. But if I take one of those not pinto beans, then my second pick only leaves me with 15 not pinto beans out of 24. 16 times 15 is 240 out of 600. But that is the probability of me not getting a single pinto bean in my 2 picks. Therefore, the chances of me getting a pinto bean, or at least one, is every other combination. So if 240 out of the 600 do not contain a pinto bead, then 360 out of the 600, which I'll circle to show as my final answer, do contain a pinto bead. Here, calculate that the 3 cards drawn are all, so it's 3 cards, okay, and we'll do this one and I'm going to let you try the rest. But the 3 cards drawn are all the letter C, so a C followed by another C, and here because we're picking 3 times, followed by another C, right? So 3 out of, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 out of 12. The second C, there'll only be 2 left, because 1 will have gone, out of 11. And the third C, there'll only be 1 left, out of 10. Times them all together, done. Okay, you work that out. The letters A, E, and O are vowels. All the other letters are consonants. Calculate the probability that the 3 cards drawn include at least 1 consonant and at least 1 vowel. Wow. Try and, right, trying to write all those again, it's that word at least. Oh dear, as soon as we see that at least, we're like, oh dear me, that's too many. All right? Do the opposite. Work out the chances of having no consonants. Then work out the chances of having no vowels. Then we can add those up, and we know the probability then of having all no consonants or all no vowels. So every other combination will contain at least one consonant and at least one vowel. Okay, so the no consonants one, 9 out of 12. Nope. Hang on. No consonants. Let's just take a look. How many are not consonants? 1, 2, 3. Sorry, my apologies. Going all around here. That's that one. So 3 out of 12 are not consonants, followed by 2 out of 11, followed by 1 out of 10. That's the probability of having no consonants, okay, in my 3 picks. The chance of having no vowels is a lot higher because there's 9 out of 12 which are no, not a vowel, followed by 8 out of 11, followed by 7 out of 10. Probability of not having a consonant there, probability of not having a vowel there. Every other combination has at least one consonant and at least one vowel in it. So whatever that works out to be, it's the rest that we need, or one take away that. Okay? Where's that at least again? Just keep just be wary of what's going on here, okay? Find the probability of the winners of the first 2 games choose the same prize. So here, they can't both choose books, because if the first one takes a book, there's no books left. So it's key ring, times those, plus pencil, times those, and add those together. Or after the winners of the first 3 games, so 3 winners, find the probability that the ticket for the book is still in the box. In other words, nobody has picked the book. So what we want here is not the book for the first person. We want the second person to not take the book. And we want the third person to not take the book. And then the book will be left. So that is the probability that the book is left. So that times that times that. Well, how many prizes are not books? 11 out of 12 to begin with. If we take something that's not a book, there's now 10 out of 11 left. And if we take that, something else that's not a book, there's 9 out of 10 left. And if we multiply those, that will tell us the probability that no books are taken. Therefore, the book remains after 3 goes. You try the rest yourself. That's the end of this video. All the best.